Erosion and transporting agents. So this is the movement of particles. Okay. So, process of transporting sediments from their place of origin and depositing them elsewhere. Sometimes they can go really, really far. Sometimes they only go a couple of inches from where they fell. So these different types of transporting agents. You have gravity and glaciers. Those actually go hand in hand with some key concepts we're going to get to. And then wind and water. Those also kind of go together with some relationships and different things that we'll talk about. Okay, first one we'll talk about is gravity. Gravity is what pulls things down towards the center of the earth. Gravity can cause a lot of havoc sometimes. Okay, this was actually a landslide that broke a road. Then we have water. Water can actually gouge through different areas pretty well. Water also has the effects of the oceans coming in and affecting things as well. It doesn't just have to be traveling water that way. It's the movement of water coming in and out as well. In fact, under this tree, it used to be covered in sand until all the water came in and started to wash it away over time. Then we have glaciers. Glaciers are those giant ice cubes that are on land and they do slowly move. Glaciers are moving all the time. They don't seem like it, but they move ever so slowly. And then you have wind. Wind will cause sediments to fly around, and actually this curved part in here, that was all caused by wind of blowing the sand particles around over hundreds of thousands of years, causing that large arch. So these transported sediments versus residual sediments. So transported probably means that it moved, because when you transport something, you move something. And residual means that it stays or it's not moved from where it broke off. Okay, so transported rock material has been transported from its place of origin. Residual has been weathered and it remains the place where it broke off. So gravity and erosion. Gravity is the driving force behind most of transporting agents of erosion. Gravity is actually what causes glaciers to move downhill. Gravity is what causes water to move downhill, all those different things. And then we have mass movement. So this is when you have large movements of sediments all at once down a slope. And there's a couple different kinds of those. But what affects that mass movement is how steep the slope is. Obviously, it's very similar to you sliding down a hill on a sled, that the steeper the slope, the faster you're going to go, the more it's going to move you. Whereas when your slope's pretty gradual, not going to go so fast, not going to go so far. So the steeper the slope, the more the mass movement. So this depends on the amount of precipitation that happens. More rain means more water, means more movement. So very heavy rains, the spring melting of snow, especially around here, spring melts of snow can cause a lot of mass movement sometimes. So there's these different types of soil movements. You have soil creep. I have a couple of pictures to show you. Soil creep, because if you're going to creep along, creeping actually moves, it means it's very slow moving. Debris flow is this rapid downslope of plastic flow, which means that everything is just kind of moving like goop, basically. Then you have mud flow, which makes things move a little bit faster. It's just more of a mud consistency, more water into it. And then you have rock falls, which is the rapid falling of rocks off of the side of a cliff usually. So this is what soil creep looks like. Kind of slowly moves its way down the hill. As you can see that the slope of this hill is actually not too steep, but the soil still is creeping along. Every time it rains, some of that soil gets caught and it causes those ripples until it falls over the ripples and goes to the next one. Debris flow, so this is where you have large movements of things. Actually, debris flows can cause whole houses to move down the sides of mountains or down the sides of hills. Mud flows, it's more of liquidy form, like I told you, that there's a lot of times mud flows happen with floods because it's just picking up so much sediment, but it's very like liquidy. And then the other one was the rockfall piece. But everything that has to do with glaciers and gravity are angular angular, and the other word we're going to get into is unsorted, meaning it's not nicely sorted. So there's a couple different dominant types of water movement. You have rain, stream erosion, and oceans. So the first one is rain. You have dislodged runoff, I have to sneeze, and it went away, which sediments can flow down slopes, maybe not, keeps coming and going. So what's susceptible to this? Farms. Farms have to be really careful with these erosion movements with water, because a lot of times they're wide open fields, all of their soils and sediments are exposed. So they have to be careful of how they grow things and what they do. Because of those exposure times, it can cause a lot of runoff and different things like that. Construction sites are like that too, and it's all because they're wide open. So with stream erosion, there's different ways things travel through the water. You have stuff that's in solution. Anything that's in solution means that it is a dissolved particle. Okay, it's never going to settle or go down to the bottom unless water starts to disappear. So anything that's in solution in a river is always constantly floating around. If something is in suspension, this is like your sand, silt, and clay. This is the stuff that's going to float around, excuse me, and eventually when the water slows down, it's going to drop down very slowly. And then you have your stuff that's in siltation or bedload. Those are those big rocks that are going to roll along the bottom, and they're going to kind of bounce along the bottom too. So solution, always dissolved, flowing around, moving nicely. Suspension, kind of floating around, but eventually can sink down to the bottom. Siltation or bedload, rolling around down the bottom or bouncing on the bottom. The animation doesn't work anymore because Flash doesn't work anymore, which is really sad. So the carrying power, the faster the water is moving, the bigger the size particle that can get moved. So stream discharge means that the amount of water that's flowing through past a given point. So if you have a lot of water going through at once, that's a lot of stream discharge all at once. And that usually depends on the amount of rain that's happened that day or days prior to, and the amount of snow melt sometimes, depending on where it is. So these sediment sizes that you are going to write down are found in your handy dandy reference tables. And if you look on page 6 of your reference tables, you can actually find it here on this chart. And this is what we're going to learn how to use. If you're really looking, you also can find it in the sedimentary rock one, but this is the easiest place on page 6 to find that. So, higher the slope, faster the water is going to move. Stream discharge means the amount of water. More water, it's going to move faster. If the shape change of the channel, the more circular it is, the faster the water is going to move. So then we have this relationship. This is the page 6 chart I was telling you about, the relationship of transported particle size to water velocity. This chart is a little confusing, but once I show you how to use it, it's not too bad. So down here at the bottom, stream velocity, how fast the water is moving. They didn't put it on here nicely. They wanted to fit a crap ton of speeds on here, but they didn't have a big enough piece of paper for it. So what they did was they separated each one of these chunks. So down here, this is the 100th chunk, this is the 10th chunk, this is the 1s, 10s, and 100s. So from here it goes from 100 to 1,000. Here it goes from 10 to 100. Here it goes from 1 to 10, so on and so forth. So you just kind of have to realize where you are in terms of the velocity. So that's the speed. Then you have the particle diameter, how big the actual particle is. And those specific diameters that split them are right here. Okay? The black line that looks like somebody just went, okay? That's the spot of how fast the water has to be moving to move a certain size particle. So what happens is well, particles can be carried in a stream with a velocity of 50 centimeters per second. So if I go to 50 centimeters per second, which is right here, I'm gonna follow that up. It hits about a 1 centimeter diameter particle. Specifically, it can move pebbles. If it can move pebbles, it moves everything else underneath it. So basically it can move some pebbles, because it's not moving all of them. It can only move pebbles up to the size of 1 centimeter in diameter, but it can move all sand, all silt, and all clay. Okay? Does it come up with the answer? No, of course it's not, because I didn't write it in. So, what is the slowest a stream can flow to carry a 6.4 centimeter cobble or pebble? So this is what you're gonna do. You go to 6.4, okay? I found the black line. I'm gonna follow it straight down, and it is almost like 200 centimeters per second. So the water has to be moving at 200 centimeters per second in order for the biggest pebble to move, okay? So what particles can be carried in a stream with a velocity of 100 centimeters per second? So if I go, no, it's too far. 100 centimeters per second, the largest particle I could move is a somewhat big pebble, okay? And then what's the slowest a stream can flow to carry a 0.2 size pebble sand? So if I go 0.2, I've got to go down, it's got to be at least 10 centimeters per second. Okay, so the channel shape and velocity, I'm going to do another lesson on this, but you do need to know and understand how this all works. So make sure you pay attention to this, but also when I do the other assignment, you still watch that video and go along with it too. But streams, they curve. Why do they curve? Because of the water. Water travels at different speeds, different parts of a river. So the greatest velocity is on the outsides of the curves, and this is where erosion is taking place because water's moving faster, it can carry more particles, it's going to cause the erosion to happen there. The slowest velocity is on the inside of the curve. This is where deposition takes place. So because on the insides of the curve, water's not moving so fast, it can't move those particles, it's going to drop them off there. So you can see here, erosion's happening, like it said, on the outsides of the curves. Deposition you can see building up on the insides of the curves. Water's moving the fastest on the outside. It's moving a little slower on the insides here. Okay, so the channel shape and velocity, the position of maximum velocity and extreme cross section varies with the direction of the stream flow. If a stream is going straight, the fastest water is smack dab in the middle just below the surface. If it is curving, the fastest velocity of the water is going to be on the outsides of the curves, and the slowest is on the inside. When it starts to straighten out, the fastest water is going to be down the middle. So there's different life cycles of streams. Youthful streams are going to be steep and slope. If they're steep, that means the water is going to be moving faster. This is going to cause deeper canyons because it's going to erode more, and it's going to have some rapids and waterfalls. For example, the Colorado River is a good example. Lots of rapids, lots of, not tons of waterfalls, but lots of rapids because the water's moving pretty fast through there. Colorado River is a really cool place to go river rafting. So as these streams and rivers start to mature, their slope is going to decrease. It's not going to be as steep. They form these meanders. Meanders are what the twists are called. You need to know what meanders mean. So meanders are twists. The description is going to have wider valleys, gentle slopes. The Hudson River actually is a really good example of a mature river. There are still curves, but they're starting to get pretty windy. Okay. An oxbow lake is when those meanders and curves get so meandery and curvy that they actually cause deposition to happen. It rains really hard one day, it straightens out the river, and it cuts off. It can cut off one of the parts of the meanders, and it causes a lake. So you can see here's all these meanderings going through. This one right here, this will eventually kind of This will curve in more, this will curve up more until it might rain one day and cause this to straighten out. This can cause an oxbow lake here. And then you have your really old age rivers and streams. Slope's gonna be really low, water's gonna move really slow, large meanders, flat surroundings, lots of oxbow lakes that happen with this one, lots of deposition. The Mississippi is pretty old. The other one that around here that's pretty old is the Battenkill. That one has a lot of meanders, lots of little oxbows, kind of goes all over the place. So what happens when it floods sometimes is you have your water come through here. Water moves really fast during floods, stirs things up, and once everything kind of starts to settle back down, all of that sediment that was once down at the bottom of the river is now on the sides. Sometimes those rivers start to move faster because there's less sediment in the base of them. This is actually a cool diagram that I like to show everybody every year of like where to build your house and where not to build your house, and to make sure that if you are buying a house, that your house is not built on a floodplain, because that's basically what these are. You can see, oh, stop it. That's what a floodplain is. Anything that is right next to the river that potentially when it does flood, it will flood up on there. So here in this picture, you can see, oh, look at it. It's like a nice little river. Oh no, it's raining. It's causing it to flood because that kind of happens there. You're near a river. Oh, and it causes nice meanders, some different things happening. Well, then people come along. Oh, look at this nice river. We want to build our houses next to it and make lots of money. So what they do is they'll build the houses, they'll redirect the river, and then they build all these wonderful expensive houses, and then they have a really bad storm and everybody gets flooded out, nobody knows about it, and somebody else makes lots of money. Okay? So that's why when you buy your house, anytime near a river, you need to make sure that the house is not at the level of the floodplain, because otherwise your basement floods, your house might get flooded. There's a whole different, lots of different scenarios. Because around here, there was a hurricane a couple years ago that caused the river to flood, and it caused other areas surrounding to flood pretty bad because those areas were in the floodplain area or were lower than the level of the river, and it doesn't drain out very fast. So now, anything to do with wind and water, it is going to be rounded and sorted. It's going to be smooth from abrasion. It causes it to be rounded. Okay? Waves can cause things to be rounded. They drag against the bottom, it erodes the shores and cliffs, and it causes these long shore currents. That's something you need to know. Water comes at an angle and it carries large amounts of sediments. This also can create sandbars. So particles in a wave get moved around over and over and over and over again. So if you actually were to take sand particles out at the beach, you would notice that they are very rounded and smooth. They look pretty cool when they're under microscopes. Wind does a similar thing. When wind blows, it causes these particles to roll and roll and roll and roll around, and they basically get to be rounded. This happens out in the Midwest. It's carried by suspension and bouncing, because remember, suspension means it kind of blows through the air, or it goes through the water, but it bounces along the way too. Okay, and all those particles are going to be rounded and frosted. Frosted's another word for meaning just like it gouges out and things get pitted. Okay, this is an area in Arena, Wisconsin. It can be prevented. So what they do is they need to prevent wind erosion. So wind's gonna blow through no matter what. But there's different things we can put into place in order to prevent extreme wind erosions. Glaciers, they are naturally formed masses of ice and snow. They move downhill on land under the influence of gravity. Glaciers are pretty cool. So how is sediment carried in a glacier? It's carried through like a snowplow, okay? It's all picked up together and it gets moved like a snowplow. Most of New York State shows evidence of glacial erosion. Long Island is the best example. Long Island is a huge island that is made from a glacier pushing sediment until it's stopped, okay? All of those particles are angular and rough, and they can be scratched and grooved. So glaciers and gravity are angular and unsorted, and wind and water are rounded and sorted. Glaciers create U-shaped valleys, and rivers create V-shaped valleys. That's how you need to remember that. Rivers create V-shaped valleys, and glaciers create U-shaped valleys. So, humans. The erosion of land through natural processes can take a long time, but human activity, we can cause things to happen almost overnight and destroy things. Okay. Watersheds, this is something you do need to know for the test. A watershed is an area drained by a system and its tributaries. Tributaries are the bodies of water that feed into a larger body of water. And a watershed is just the whole area of everything draining into it. I think you might need to write this one in. If not, just fill it in the right way. Okay? That was erosion and transported sediments.